Welcome back to the Deep Dive. Today, we are tackling something that I think, well, a lot of us just take for granted. We're talking about the operating system of the human mind.
That's a good way to put it.
And I don't just mean that as a metaphor. We are looking at a text today that essentially tries to rewrite the source code of human language.
It really does. We're analyzing Chapter 4, Categories and Transformations, from a foundational work on the Minimalist Program. And rewrite is exactly the right word.
Right.
This isn't just about tweaking grammar rules. This is asking a much, much bigger question. Is language, at its very core, a perfect system?
See, that's the hook that got me, perfection. Because when I look at biology, and language is a biological trait, let's be real, I don't see perfection. I see a mess.
Yeah, it's usually quite messy.
I see evolution just, duct taping things together. We have appendices we don't need. We have back pain because we stood up too fast. Evolution is a tinkerer. It's messy.
Precisely. In biology, the term is bricoleur. It uses whatever junk is lying around to solve a problem. But the source material we're covering today proposes a radical conjecture.
Okay.
It suggests that the language faculty, that specific bit of our brain that lets us talk right now, might be different. It might actually be an optimal solution to a very specific engineering problem.
That is a massive claim. It's like finding a perfect diamond in a pile of rusty spare parts.
It is.
So the mission for this deep dive is to see if we can actually back that up. Can we strip away all the complex, maybe arbitrary rules of old-school linguistics and find a simple, efficient engine underneath it all?
Exactly. We're cleaning house. The goal is to derive language on what the source calls principled grounds. So if something in language looks complex, the idea is to prove it's not just some random accident of history,
but a necessary result of something much simpler.
a necessary result of satisfying very basic constraints.
Okay, so let's pop the hood. Let's look at this engine. The text calls it the computational system, or CHL dollar.
Right, CHL dollars. The computational system for human language. Think of it as the processor.
So how does this machine even switch on? It has to start somewhere.
It starts with enumeration. Imagine you have a mental dictionary with thousands of words in it.
Okay.
To build a sentence, you first select a specific bundle of words, lexical items, that you want to use. You sort of put them in a temporary bag. That bag is the numeration.
Got it. A bag of parts.
And the system's whole job is to take that bag of parts and map it to two very specific interfaces.
That sounds like computer inputs. What are we plugging this bag of words into?
Into the human being.
Yeah.
We have two systems that the language engine has to satisfy. One is the sensoromotor system. That's the output.
The sound, the physical act of it all?
The sound, sign language, yeah. We call that the phonetic form, or PF.
Okay, so that's the noise I'm making right now.
Correct. The other interface is the conceptual intentional system. That's the mind. Thought, meaning, interpretation. And we call that logical form, or LF.
So this perfect system is really just a bridge. Its only job is to take a bag of words and arrange them so they're pronounceable at one end, the PF, and meaningful at the other, the LF.
That's it. And the argument for perfection comes from how it does that. It doesn't use a million different tools. It relies on just two primary operations: merge and attract.
Which we usually just call move. Exactly.
Merge seems, obvious. You can't have language if you can't stick two things together. You take the and cat, merge them, you get the cat. That seems inescapable.
Merge is inescapable. Any system that builds structure needs a way to combine elements. But move, or attract, that's where things get, well, controversial. This is where the skeptics jump in.
Ray, I wanted to push on this. If this system is so perfect and economical, why on earth are we moving things around? Why not just say words in the order we think of them? Like, you bought what? Instead of, what did you buy? And that is the central puzzle. In a truly lazy system, move shouldn't exist. It's computationally expensive to pick something up from the bottom of a structure and drag it all the way to the top.
So the Minimalist Program has an answer for this?
It does. It argues that movement is a last resort.
A last resort? That sounds a bit dramatic.
It is. It means you never move an element for style or for emphasis. The system only moves something if the whole derivation is going to crash without it.
So it's forced to.
It's forced by the morphology, the little bits and pieces on the words themselves.
The system is just fundamentally lazy then. It wants to do the absolute bare minimum.
It's ruthlessly efficient. It operates on what are called economy conditions. It looks for the shortest, cheapest path to satisfy those two interfaces, PF and LF. It's not checking every possible way to say a sentence.
Just the path of least resistance.
Exactly.
There's a point in this process called spell out that seemed really critical in the text. You described it to me before as a kind of divorce.
That's a great way to think about it. Spell out is the fork in the road. The system is building structure, and then snap it hits spell out. At that point, it strips away all the sounds, the phonological features, and sends them off to the mouth, to PF.
So the sound literally leaves the building.
Right. But the meaning, the abstract structure itself, it keeps going. It proceeds to the logical form, to LF. And this is crucial because after spell out, the system is essentially deaf.
It only cares about meaning.
It only cares about meaning.
I'm still stuck on the why, though. How does it know what to move? We talked about economy, but what's the currency? What are we spending?
We're checking off features. This is the fuel for the engine. Every single word you pull from that numeration bag is really just a bundle of features.
And the text splits these into two types, interpretable and non-interpretable. This felt like the real key to the whole perfection argument.
It is. Interpretable features are things that have actual semantic weight, real meaning, like the feature for plural on the word dogs. The mind needs to know there's more than one dog. That information stays all the way to the LF interface because the mind uses it to, build a picture of reality.
Okay, that's useful data. That's the cargo.
But then you have these non-interpretable features, and these are purely grammatical markers, things like case assignment, agreement markers, like the S on he walks.
It doesn't really add any new meaning.
None. It's just grammatical glue. They're like bureaucratic red tape.
Right.
And the interfaces can't handle them. If a non-interpretable feature arrives at the logical form, the meaning center, the interface, just rejects it. It says, I can't interpret this. What does nominative case even mean?
And the derivation crashes. I love that terminology. It's so mechanical.
It is. So the entire game of syntax, really, is to delete all that red tape before you reach the finish line.
So a grammatical sentence is basically just a survivor. It's a derivation that managed to check off and delete all its uninterpretable baggage before it hit the interface.
That is the definition of a grammatical sentence. If you leave even one of those features unchecked, you're not speaking English or any human language. You're just making noise.
And that explains why we move things. We move them specifically to check these boxes.
Yes. You move what to the front of the sentence to check a way feature, a question feature that's sitting up high in the structure. Once it's checked, the feature just vanishes, and the structure is safe to enter the meaning interface.
It's like a self-cleaning oven.
A self-cleaning oven. That's perfect. And that confirms this best possible way argument. The system is designed to eliminate its own imperfections in the most economical way it can.
Okay, let's zoom out a little. The text makes a really big deal about categories. Now, in old linguistics, we had these huge trees with noun phrases, verb phrases, but the source implies we can scrap a lot of that.
We can eliminate the independent theory of phrase structure. We don't need a separate rule book that says a sentence consists of a noun phrase and a verb phrase. The structure just builds itself.
Based on the features we just talked about.
Exactly.
But something has to hold it all up. If we don't have those old rules, what's the skeleton?
The functional categories. The text really zeroes in on three big ones that drive the whole machine. T, C, and D.
P, C, and D. Let's break those down. They sound like vitamins.
T is tense. It anchors the event in time, past, present, future. C is complementizer. That's usually at the very top of the tree, and it determines the force. Is this a question? Is it a statement?
It frames the whole sentence.
It frames it. And D is determiner. That's the functional head that turns a vague concept like cat into a specific object like the cat or that cat.
So what about the actual nouns and verbs, the cat and the sat? I thought those were the important parts.
They're substantive categories. They provide the meat, the content. But here's the kicker. The source argues that nouns and verbs generally don't have strong features.
And strong features are the ones that force movement.
Right. The strong features are the magnets. They do
Yeah.
the pulling.
Yeah.
And T, C, and D, the functional stuff, that's usually where the magnets are. They pull the nouns and verbs into the right slots.
So the grammar, the T, C, D is the puppet master, and the words are just the puppets.
Structurally speaking, yes. You can't just throw nouns and verbs on the floor and hope they make sense. You need that functional skeleton to hang them on.
I want to pivot now to the notes section of the text, because usually footnotes are where you go to fall asleep. But here, the source gets into some really specific, almost philosophical battles.
It really does.
There's this section on optimality theory where the author accuses it of a fallacy of perfection.
Yeah, this is a fascinating little academic skirmish. Optimality theory, or OT, is another framework in linguistics. And it basically assumes you look at an input and an output, and you pick the best output based on a ranked list of constraints. It judges the final product.
Like judging a cake just by how it tastes at the end.
Right. But the minimalist program says you can't just look at the finished cake, you have to look at the recipe steps. The text argues that crucial properties of language depend on the derivation, the intermediate steps.
Can you give me an example of why the steps would matter so much?
Well, the text mentions the concept of the cycle. You build language in phases, from the bottom up. A decision you make at step 2 completely affects what's possible at step 3. OT, by focusing only on the final output, it misses that local history.
Ah.
Minimalism says this system is locally economical.
Yeah.
It makes the best decision it can right now at this specific step without worrying about the global outcome 5 steps down the line.
It's playing chess one move at a time, looking for the best immediate move, not trying to simulate the entire game to the very end.
Exactly. If your brain tried to simulate the whole game just to find the single most perfect sentence, it would require massive computing power. Exponential blow-up, as the text puts it.
It would just freeze up.
It would freeze up. Local economy is cheap and fast.
There's another example in the notes that I have to say it kind of blew my mind. It's about expletives. And we should probably clarify, we're not talking about cursing here.
No, not at all. In linguistics, an expletive is a placeholder word, like the word there in "there's a book on the table."
Right. And the text contrasts there is a book with John has a tooth missing. Why? They sound sort of similar.
It's to show how the meaning interface, the LF, handles the concept of existence. Just think about the logic of it. When you say, there is a book, does the book exist?
Yes, of course.
Okay. Now, when you say John has a tooth missing, does the missing tooth exist?
No, that's the whole point of it being missing. It's gone.
But grammatically, the sentences look very similar. You've got a subject, a verb, an object. But the text point is that their construction forces a specific interpretation at the LF interface. It entails existence.
So there isn't just an empty slot filler. It's actually a signal to the meaning machine.
It's a specific instruction. The John sentence describes a property of John. He has a gap in his mouth. It doesn't assert that the gap exists as an entity, but there is a book, asserts the book exists.
So this proves that the logical form interface is incredibly sensitive. It's not just getting the gist of the sentence.
Not at all.
Yeah.
It's decoding precise instructions on how to view reality. The difference between a property and an existence claim is huge, logically, and the syntax just handles it effortlessly with these tiny functional words.
That's wild. A missing tooth proves the precision of our syntax.
It really does.
The text also throws in a quick mention of Bertzio's generalization. We don't have to get too deep in the weeds, but what's the headline there?
It's about connections. Bertzio noticed a pattern. If a verb doesn't assign a specific role to its subject, like an external doer of the action, it also, strangely, loses its ability to assign case to its object.
So the gears are all interlocked.
Right. You can't just break one part of the engine without affecting all the parts downstream. It's more evidence that this is a very tightly integrated system, not just a loose collection of rules.
Okay, let's touch on one more technical bit before the big finish. Linear order. The text mentions Keynes' linear correspondence axiom. That sounds terrifying.
It does sound scary, but the idea is actually very intuitive. It asks a simple question. Why do we speak in a line, one word after another?
Biology, I guess. My mouth can only make one sound at a time. I can't say a whole sentence at once.
That's the physical constraint, for sure. But is there a structural reason? Keynes argues that the linear order, left to right, maps directly onto the structural concept of higher to lower in the tree.
So if the shera comes before cat, it's because thy is structurally superior to cat.
It commands it in the jargon. Precedence in time reflects dominance in structure. The source text refines this, arguing that this ordering isn't vague, it's a literal mapping. The 3D hierarchy of your thoughts is flattened into a 1D line of speech.
It's like a shadow. The shape of the shadow implies the shape of the object that cast it.
A perfect shadow. And the source argues this mapping is a principled part of how the system works. It's not just an accident that we speak in order. The order reveals the hierarchy of the mind.
Which brings us all the way back to the radical conjecture the source ends on, this idea that language approximates a perfect system.
It's still the boldest claim in modern linguistics, I think.
But I have to play devil's advocate again. If it's so perfect, why is it so hard to learn a second language? And why is English so different from Japanese if we all have the same perfect engine in our heads?
Because the perfection is in the engine, not the paint job. The computational system merge, move, check features. that is arguably universal and perfect.
Every human has it.
Every human has it. The variation, the difference between English and Japanese, that lies in the lexicon,
In the bag of words.
in the bag of words, and, crucially, their features. It's about which features are strong and which are weak in a given language. In English, a feature might be strong and force movement. In Japanese, that same feature might be weak, so nothing moves.
So the hardware is identical, it's just that the software settings are a little different.
That's a great analogy. And the source concludes that this hardware, this language faculty, is an optimal solution to the problem of connecting sound and meaning.
Which brings us to the final, slightly existential question. If this is true, what does it say about us? You mentioned earlier that biology is usually a mess. So if we have this one perfect crystal inside our heads, how did it get there?
That is the question of the century. If language is an optimal system, it suggests it might not be the result of slow, gradual, tinkering evolution, like our spines or our eyes. You don't get perfection by slowly adding random bits over millions of years.
So it suggests something more sudden.
It suggests the core of language might be the result of a sudden emergence, governed by something like the physical laws of computation. The same way a snowflake forms a perfect geometric pattern because of the laws of physics, not because of evolution.
So we didn't evolve it so much as we just tapped into it.
Perhaps. It moves linguistics much closer to physics. We aren't just collecting butterflies anymore. We're trying to discover the laws of motion for thought.
And the source acknowledges the difficulty. It says we're left with hard and challenging problems of a new order of depth.
We've traded the messy, easy problems, like listing all the irregular verbs in English, for the elegant, almost impossible ones. Why is the mind structured this way? How does computation like this arise in a biological brain? But that's progress.
It suggests that the way we think, the very structure of our reason, might be a lot more rigid and mathematical than it feels. We feel like we're just free associating, but actually, we're running a script.
We are running a very strict, very economical script. And the fact that it works at all, that I can make a sound with my mouth and put a complex idea directly into your head, is, well, it's a miracle.
A perfect miracle. That's a lot to process. We've gone from checking grammar boxes to questioning the nature of evolutionary biology.
That's the minimalist program for you. You start with the verb, and you end with the universe.
I think that's a perfect place to stop. Thanks for helping us decode the source code today.
It was my pleasure.
And to you, listening, the next time you catch yourself correcting your own grammar, just remember, you're not being picky, you're just trying to satisfy the interface. We'll see you on the next deep dive.